Welcome to the 6th unit of the course Cloud Computing. This unit is the introduction to distributed computing. As we have mentioned in an earlier unit, every new technology has or is tied with, very intimately tied with some other technologies in various capabilities. The first is the foundation technology. The technology of cloud did not arrive on its own or suddenly. It is founded on certain other technologies, and a slow evolution created what is called cloud today. So, the cloud has essentially should have evolved from a set of technologies, that is our foundation technologies. The second is the cloud is developed based on the features of some technologies without which the typical characteristics of cloud cannot be obtained. These are called the enabling technologies. And the third set, which provides some specific requirements for the users, these are technologies which perhaps are going to change if the requirements of the users are going to change. These are what we call the dependent technology. So, let us now see for cloud which are its foundation technologies, which are its enabling technologies, and which are its dependent technologies. So, first the foundation or the underlying technologies. Cloud has essentially evolved from the distributed systems, and also it heavily relies on the principles of parallel computing. So, therefore, the foundation of cloud computing is the distributed systems and the parallel computing technologies. Next, the cloud is actually a virtualized environment. It exploits virtualization to accommodate users for more use. So, the virtualization is considered to be an enabling technology for cloud. Further, cloud provides everything as a service. So, therefore, the users get to see only that part of the implementation that is required for them to see, and this is done using the service oriented architecture, which again becomes a enabling technology. The cloud has or takes care of a large data set, and this large data set has to be managed using something which is currently being done using a P2P environment. Cloud uses a mechanism called key value stores, and these key value stores are completely implemented in a cloud using the P2P networking technology or P2P computing, so that this large data set can be handled easily in cloud. So, if we look at the definition of cloud as was given by, as we had already given by Professor Rajkumar Bhuiya, we see that the cloud is a type of parallel and distributed system. So, it is a parallel and distributed system, and that is being recognized as its foundation technology. It is a virtualized environment and it has certain services. So, virtualization and SOA are the enabling technologies, and it has the P2P as the dependent technology. So, as we have mentioned just now, to understand cloud computing properly, one has to understand the foundation technologies, which are the distributed systems and the parallel computing. To appreciate what cloud is capable of doing, we have to understand the technologies on which it is using which it is built, which are the virtualization technology and the service oriented architecture, and to understand or appreciate the way it manages the user's requirements, which is computing large data set that requires handling and managing this large data set efficiently, so that services can be provided to the users very quickly. It uses the peer to peer technology. So, to appreciate the cloud computing technology, we have to start from the distributed systems technology. The base of distributed systems technology is the client and server paradigm. So, how a client server paradigm is applicable in cloud is that the cloud applications are distributed cloud server, client server paradigm. The servers are in the provider's premises. They contain both the computation and the data. So, all computations are done in the server and all data resides in the cloud storage somewhere in other servers. So, this is the server part of the client server paradigm, and a thin client runs on the user's machine. Let us understand why it is called a thin client. In a client server paradigm, the job of the client is to ask for a specific service, and the job of the server is to provide that service. Now, in this there are lot of information that gets exchanged, and it is quite possible that some part of this information may still reside with the client and some part may reside in the server. In a thin client environment, no part of information should be residing in the client. Everything will be done by the server. The client acts as a simple interface or a web browser to access or communicate with the server. Cloud follows a thin client module where client's side is very limited, everything is residing in the server side. So, why cloud is called a distributed environment, or why distributed system is the fundamental technology for cloud? Cloud is nothing but a very large distributed system which is offering its services to everybody who is trying to access the service on demand. So, cloud essentially is nothing but a kind of distributed system. Therefore, distributed system is the foundation for cloud. Now, let us look at the confusion between what is a distributed system and what is a distributed computing. Are these two related or they are different? Basically, distributed system is a software system in which components are located on the networked computers which are communicating and coordinating their actions by message passing. So, a distributed system is something that is a software system where the systems or the communicating processes are distributed geographically. Now, a distributed computing is a field of computer science which studies distributed systems. In this course, we will be often mentioning distributed systems, also distributed computing, and we will be meaning them equivalently. So, a distributed computing is quite equivalent to a distributed system unless we mention specifically otherwise. So, let us look at the definition of a distributed system. According to the basic definition, it says that a distributed system is a collection of computers linked by a computer network that appear to the users of the system as a single computer. So, a distributed system actually consists of a number of computers. These computers need to be connected using a networking, but they should look to the users as a single computer. So, the appearance of a single computer is actually an illusion, but the distributed system creates this environment where this illusion looks real to the users. So, what are the benefits of a distributed system? We share resources. Resource sharing is a very important aspect for a distributed system. If we imagine various resources which are present in geographically different locations, then accessing these resources is possible only if we have a distributed environment and these geographically dispersed systems are connected with each other. Next is reliability. Essentially, reliability indicates the availability of the resources. Since it is a distributed environment, a resource can be present in multiple locations, and even if there is a problem with one of the systems, other availability of the resources can be used by the users. So, therefore, resources in a distributed system is always very reliable. The speed of computation in a distributed system happens because multiple the processes of an application can be simultaneously or concurrently executed on different platforms. Communication is the next advantage or benefit of a distributed system. Here the users and the processes are able to communicate using an easy message passing environment. Then comes the incremental growth. Since a distributed system is a network based connection of multiple geographically located computers, it is very simple or easy to add or delete certain systems using the similar networking technology. So, incremental growth indicates that I can add more systems to the environment without affecting the current workings of the system. Now, since every technology comes with certain challenges, distributed systems also is not devoid of that. The challenges or rather the design challenges for creating a distributed system are first the heterogeneity. The components are heterogeneous, which means that various computers which are being connected using networking and are created as part of the distributed environment are not necessarily belong to the same group. So, therefore, how they are going to communicate with each other is a design challenge. Openness is a design challenge because the components should be replaced easily and the interfaces also should be easily replaceable. Availability is a challenge because if a part of the network is down, even then because availability is a benefit of distributed systems, we have to provide availability to the users. Security is definitely a challenge because the system is accessible to various users and therefore, the system should be always used in a secured manner. Scalability proves to be a very major challenge in a distributed environment. Basically, the concept of scalability is that the nodes can be added and deleted without affecting the workings of the system. This proves to be particularly difficult because of various collaborative algorithms or processes that are run in a distributed environment. We will come to see the problem of scalability at a later stage. The other design challenges are failure handling. No part of failure of one or more components should affect the working of the environment. Concurrency, since various parts of an application can run on different parts of the distributed system, how they are to be sharing the resources are a challenge which is called the concurrency challenge in a distributed environment. And of course, transparency is a big challenge, since we need the system to be looking or appearing as a single system to the users, and this characteristic is called the transparency of a distributed environment. This becomes a very major challenge to the designers of a distributed environment. Basically, transparency requires that no part of the geographic distribution should be visible to the users. There are various ways we can look at transparency. Essentially, there are 7 types of transparencies that are available. The first is called the access transparency, which requires us to hide the different ways that data and computations are accessed, essentially the interoperability challenge. Then the location transparency, which requires the providers to ensure that the location of the resource is not known to the user, which means that the user should have the illusion that everything is located inside the machine from which the user is accessing. Then we often need to migrate resources from one location to the other, but it should be transparent to the users, which is the migration transparency. Multiple resources are being handled or accessed together or shared together at the same time. This is the shared concurrent sharing of resources, and it should not be visible to the user. Whatever failures may happen, the system should still run without getting affected, and that is the failure transparency. In a similar vein as migration, we may need to relocate some resources even while it is being used, and that is the relocation transparency. And last but not the least, because of the requirement that the resources should be always accessible in spite of any failures that happen, redundancy or multiple copies of the resources are amply used in the distributed environment, and this is called a replication, and the replication should be transparent to the users, which means that the user should not be affected, or the usage of the user should not be affected by the fact that the user is using a replicated copy of the data. Now, many of these characteristics are of interest in cloud. Particularly, we see that a continuous availability is a must in cloud. scalability is a very major requirement in cloud, and the concurrency or accessing multiple users accessing together is also a challenge that cloud has. So, from this discussion we can easily understand why distributed systems is the foundation of cloud computing. But apart from that, let us also look at how exactly the cloud has evolved from the distributed environment. So, if we look at this diagram, we can see that starting in 1950s, where the first mainframe UNIVAC, as we discussed in our first unit, was developed, then slowly people developed the supercomputer. Then in 1966, the first division of the various taxonomy came, which is the Flint's taxonomy. Then in 69, ARPANET came, which is considered to be the forerunner of internet. Ethernet was invented by Xerox PARC. Ethernet and LAN came after that, and slowly as we go, we see that we have the cluster coming up, we have the TCP/IP being standardized, we have the invention of www, HTTP, HTML. Then in 1999 came the grid computing. This is the perhaps the most important part of cloud of distributed environment. Then slowly the other environments developed, which are the AWS, the Aneka, Microsoft Aneka, Google App Engine, and Microsoft Azure, and so on. So, if we look at this, we see that there have been three major developments. One is the initial development of the mainframes. Then mainframe gave way to what is known as the clusters of computers, and cluster of computers encouraged the development of the grid computing, and with the advent of grid computing came the concept of cloud computing. So, essentially the three major milestones that have led to cloud computing are the mainframe computing, the cluster computing, and the grid computing. We will now look at these three to try and understand how cloud computing evolved from these. So, the mainframe computing is essentially the invention of large computers, which are called mainframes, and these computers are very much capable of large data movement and huge computation and I/O operations. They used to be bulky, large, but their main idea is that they would always be available. Mainframes would never shut down very easily. A small error cannot shut down a mainframe was the requirement. Then came the cluster computing. Essentially, a cluster is a collection of standalone computers, but they are interconnected with each other, which has the requirement that they work collectively and cooperatively to create a single integrated resource pool. So, this is what a cluster looks like, and together they are supposed to work for a specific problem. So, it is now being used as a supercomputer. So, a supercomputer can either be created using large mainframes, or alternatively, as is being very much done today, it can be created using a large number of computers in a cluster environment, which are cheap commodity machines, and these will be connected using a high bandwidth software tools to create a single system. What are the benefits of these clusters? They are that they have massive parallelism, which means that programs can run in parallel in small cluster machines, and together they can give very good result fast. The specific benefits are that it is scalable, any number of nodes can be added, it is highly available, even if some nodes are down, other nodes will be available. It is fault tolerant similarly, and it has a modular growth. One can add components to a cluster computing, and the components are cheap, which are commodity components. So, what is the specific interest in cluster computing is that they are used to create large computational grids. In many laboratories they are being used. Business data centers are all generated using clusters. Supercomputer sites are being generated using clusters, and specifically our interest is that virtualized cloud platforms are being generated using clusters. So, the easy scale up and scale down are the first important characteristic. A single system image, or it is known as SSI, is an important aspect of a cluster, where we see an example here where one particular machine, if it has 300 megaflops per second processor speed, 512 MB memory, 4 GB hard disk, and it can support 50 active users and 1000 processes, and if we are able to connect 100 such machines, we get a huge capability of 30 gigaflops per second processor, 50 GB of RAM, 400 GB of hard disk, and this system can support 5000 active users and 1 million processes. So, this perhaps gives us the basic idea of how cluster is benefiting the environment. The next characteristic is the availability, which means that it is always available in a cost effective manner. So, this cluster technology contributes considerably to the evolution of tools and frameworks in a distributed computing. Interesting result or statistics is that in 2009 it was reported that 417 of the topmost 500 supercomputers were built using the cluster technology. Clusters have laid the necessary foundation for building the large grids. So, the next is the grid computing. The grid is a collection of computer resources from multiple locations to reach the common goal. Grid is a distributed environment which coordinates resources and uses standard practices. This is specifically created for dispersed geographical locations and particularly useful for scientific calculations. They are loosely coupled, diverse, dynamic, and it is managed. So, if we look at cloud, we see that the infinite capability, fault tolerance, and always on are the characteristics from mainframes. The built using small nodes or commodity machines are the characteristics from cluster computing, and it is utility computing are the characteristics taken from grid computing. So, in summary, we have seen in this unit today that the foundation technology of cloud is the distributed and the parallel computing. The enabling technologies of cloud are virtualization and software SOA, and the dependent technologies are the P2P. We have seen how the distributed computing had helped cloud computing to evolve, and we saw the three parts of cloud computing which have distributed computing which have influenced the cloud computing are the mainframe computing, the cluster computing, and the grid computing.